Okay, let's start. Hi guys, welcome to NEET World YouTube channel and NEET World Institute. So in this session we are going to see the EAPCET PYQs of work, energy and power. Yes, especially that is this series is of EAPCET aspirant for upcoming examination, that is 2026, for both engineering stream and medical stream. As of now we were in the topic like work, energy and power, right? So we have completed the topic of the work, energy and power, like we have discussed many problems of that also. And in today's session particularly we are going to concentrate on this work, energy, power PYQs, that is EAPCET PYQs. Okay, so first we'll see the question and what are the things they have given and how we need to approach each question, like different type of questions. Okay, everything we will see in this class. Okay, fine. So let's wait for 1 or 2 minutes, like people are joining over here. Okay. Okay, so let's start. So before going into the topic now, let's discuss what are the formulas are there. We have discussed everything. Okay, fine. So the topic which we are going to see is work, energy, energy and power, right? Okay, first thing about work. So we'll see the formulas and we'll go for the next topic. We'll see the formulas, next topic formulas. Okay, and then finally we go for the questionnaire session. Right? So work formula is nothing but W is equals to F dot S. So we know that force is a vector and displacement is a vector. When I do both vector with a dot product, I will get a scalar. Okay, this is the first point, and the second point is work. I can say that is FD cos theta or Fs cos theta. Right? Then the another form, like how we can take is a variable force. This is a constant force. Okay, variable force. W is equals to integral x1 to x2 f dot dx or ds, s1 to s2 f dot ds, right? Then this is first one, second one, and the third one is area under the graph, that is fs graph. Okay, this is about work, right? Yes, the SI unit. What is SI unit? Either I can say it is Newton meter or else joules, right? Dimensional formula. What about dimensional formula? First thing we should know that dimensional formula is denoted by, it's denoted in square brackets. So force and displacement, right? Force ml t power minus 2 and displacement is L. So it is m L square t power minus 2. Right? So these are the basic things we should know before entering into the questionnaire session. Okay. Whenever we have completed, like whenever we are completing the chapters, we need to see the summary. Right? Know whatever we have completed or whatever the formulas we have came across. Right? So those formulas we need to revise it, and then we should go into the questionnaire session. Then only we can know like what is the formulas used there and what formula we can use here, everything. Okay, yes. So next one, what is this? Energy. energy. So basically we know that energy, it's a capacity to do work. Okay, so two types of energy we have seen. So one is kinetic energy and one is potential energy. The sum of these two energies is known as total energy or mechanical energy, we will say. So what about kinetic energy? Kinetic energy formula is of mv square. Potential energy formula is mgh. Next, one more thing we have seen that kinetic energy in terms of momentum. Kinetic energy will be equals to p square by 2m. Right? So this one we have seen. What about the force which we are talking in a spring? Spring is there, okay? Spring is there. It's a constant is k. Okay, it has been extended, like force has been applied, it has been extended or compression, whatever it is. So it is F is equals to kx is the spring force. Let me write the note like this: spring force. What about the work done by the spring? So it is minus 1 by 2 kx square. This is work done by the spring. Right now, then what is the potential energy of the spring? Potential energy usually we will denote it by U. Right now, so U will be equals to 1 by 2 kx square. 1 by 2 kx square. Right? So this is the thing in the spring, and these are the energy formulas like of mv square mgh. Okay? So next we have seen, that is, wait a minute, yeah, one more thing is work done is nothing but change in kinetic energy, and one more thing is work done is nothing but minus change in potential energy. Right now, so I can say this is kinetic energy final minus kinetic energy initial. This one minus of potential energy final minus potential energy initial, which is ui minus uf. Here uf kf minus ai. Okay, this is about the energy. Then we have discussed about the curve, potential curve, right? So what is the thing? Force and potential, like F is equals to minus du by dx. The relation between conservative force and the potential, right? No, potential. Okay, fine. Then what else? Power. Power, no. So power, it is P is equals to W by T. What is W? Like work done. Work done by time, per unit time. Another formula is P is equals to force into velocity. Okay, force into velocity. Okay. So when I talk about FV graph, like area under FV graph gives power. Right now? Yes. And the SI unit is watt. SI unit is watt. Then what is the dimensional formula? Dimensional formula, how we need to denote it? It is MLT. So what is dimensional formula for work done? It is M L square T power minus 2 divided by T time, no? So if it goes up, it will be M L square T power minus 3. M L square T power minus 3 is the dimensional formula for the power. Sir, you have not told what is the dimensional formula for energy. So energy, both energy and work done have same dimensional formula. Okay. Yes. So this is the simple glance about the topic. Okay. Once you can go through this, then we can go for the problem. Okay. So once first slide, second slide, and third slide, three slides we have discussed, and then we'll go for the problem point of view. first slide, this is the second slide, energy. Next slide, like power. Done? Okay, so let's go for the questionnaires now. The first question is, if a force F is equals to, if a force F is equals to, wait a minute, let me take pen. F is equals to 3I minus 2J Newton. Force is given, F is equals to 3I minus 2J Newton. Okay, acting on a body displaces it from point 1 comma 2 to 2 comma 0. Then work done by the forces. So work done by the force they are asking. Okay, so can you give answer for this question? So options are there, like option A 5 joules, option B 6 joules, option C 4 joules, and option D is 7 joules. So which of the correct option for this question? So whoever watching in online, they can give answer in the comment boxes. Fast. Okay, fine. Let me give a hint of this. Okay, so 1 meter and 2 meter, 2 meter and 0 meter, like 1 comma 2 to 2 comma 0. Right now, so how we can do this is, I can say xi, yi, and this is xf, yf. Why I am saying x initial, y initial, x final, y final, which is change in displacement. No, change in displacement I need to know. It is position they have given, right? Position they have given. Change in position, I will get the displacement. So 2 minus 1 is 1 I cap, 1 I cap. Then 0 minus 2 is minus 2 j cap. Right now, minus 2 j cap. So if I do a dot product for this f and s, no, I will get a work done. I will get the work done. So can you give answer, ma'am? So 3 into 1 is 3 and minus 2 into minus 2 is 4. So it will be 7. Right now? Yes. So let's see the answer. So work done is given, F is equals to minus 3i minus 2j Newton, and the same thing, 2 minus 1 I cap plus 0 minus 2 of j cap will be nothing but I minus 2j. When I do a dot product, 3 into 1 and minus 2 into minus 2. So this is 3 plus 4, answer is 7 joules. Right? Yes, you can take a note of this and we'll go for the next question. Okay, the next question. So if a force 6x square minus 4x Newton acts on a body of a mass 10 kg, then work done by the force in displacing a body from x is equals to 2 meter to x is equals to 4 meter. So what are the given terms are there? First of all, force is there, F is equals to 6x square minus 4x, and mass is there, that is 10 kg. Then x initial is 2 meter and x final is 4 meter. So when we talk about a force which is in x, that is a variable force, we can say it's not a constant force, right? And x is also given that x is equals to 2 and x is equals to 4. What about mass? Like, to confuse you people know, like sometimes they can give the extra variable. So simple thing, I can say that work done is equals to integral x initial to x final f dot dx. That's it. So there is no use of mass. There is no use of mass. So can you give answer for this question now? And which is the correct option from A to B, A to B in this? Okay, so let's see the answer now. Okay, now what we will do, integral from 2 to 4, that is 6x square minus 4x. So what is the integration of 6x square? 6x cube by 3 minus 4x square by 2 from 2 to 4. So 6 and 3 ones are 6 twos are, 3 twos are, right, and 2 ones are 2 twos are. So what will be the things? 2x cube minus 2x square from 2 to 4. So let me write down here, 2 into 4 cube minus 2 into how much? Again it is 4 cube only. It's like 4 square, no? So 4 square. Then minus of 2 into 2 cube minus 2 into 2 square. Right? So how much 4 cube? 4 fours are 16, 16 fours are 64, right? Yes. So 2 into 64 minus 2 into 16, right? 2 into 64, 2 into 16. I'll keep this one as it is, and this is 16. This is 16 minus, and this is again 8. Okay. So what about this 128 minus 32, and this is minus of 8 will come. Minus of 8 will come, right? No. So how much will be the remaining of this? How much will be remaining? Simple. So 128 minus 40 will be the thing. 128 minus 40. So 88 will be the answer. That's it, no? 120 minus 40 is 80, and this plus 8, 88. So option D is the answer. Right? So how many of you got option A, B, C? Okay, so you got now. So it's not A, B, and C. It's option D is the correct answer for this question. Next question. Yes. So the next question is a circular well of a diameter 2 meters. So what is the thing they are given? First thing, given diameter is equals to 2 meter. Okay. as a water up to ground level if the bottom of the well is depth. So height is equals to 14 meter. The time taken in a second to empty a well using 1.4 kilowatt motor. So 1.4 kilowatt motor, power is equals to 1.4 into 10 power 3 watt. How much? The time taken in a second to empty well. So this is the equation. So we need to proceed with that. So give answer for this question. We'll see who is going to give answer for this question. And whoever joined now know like in the YouTube channel. So this in this session only we are going to deal with EAPCET PYQs of work energy and power. So we have solved so many questions in the last 2-3 sessions of the work energy and power, right? And in this session the practice questions will be there, right? Okay, so give answer for this question first. Done. Okay, so let's see the answer. Okay, so first thing, a diameter. So 2 meter, no, so radius will be 1 meter. Okay, and depth is 14 meter, right? So volume and the mass. So what's the relation between the mass? Like density equals to mass by volume. So volume will be mass by density, or mass will be volume into density, right? So volume we know that pi r square h, pi r square h, it's a cylinder, right? Okay, so pi r square h, pi into 1 square into 14, so it is 14 pi meter cube, and mass will be like 1000 into 14 pi, right? Mass like water, no, we are talking about water. Okay, so 1000 into 14 pi, which is nothing but 14,000 pi kg. So this is the thing from the question we have derived. Next thing, average height lifted. Average height in the sense like water near depth like must be lifted a distance y. So average y for column 0 to h will be 0 plus h by 2, which is nothing but 7 meter. 7 meter. So effectively we lift mass to 7 meter. Work done will be mgh. That is mgy, whatever it is. Okay. So 14,000 pi dot 10 into 7, which is nothing but 9,80,000 pi, which is around 3.08 10 power 6 joules. So this is the work done. So I am taking this work done and substituting in this equation, which is nothing but power is equals to work done by time. Power is equals to work done by time. The time I need to find. So it is work done by power. So work done we know that it is 998. So 9,80,000 pi divided by 14,000. That's it. So we'll get around 2,200 seconds. 2,200 seconds. So this is the answer for the given question. So option B is the correct answer. Option B is the correct answer. Right? Okay, so we'll see the next question. A car of mass 2000 kg is accelerating from rest. If its engine is supplying a constant power of 10 kilowatt, then the velocity of the car at 10 seconds is. So what is the velocity they are asking? So what is the answer for this given question? Yes, fast. Done. So what is the answer for this question? Okay. Okay, we'll check it. Okay. You are saying option B, option C. Okay, let's see. So car under a constant power, right? So mass is given 2000 kg and the power is 10 kilowatt, which is nothing but I can say that 10 into 10 power 3, right? That is 10,000. Fine. Now initial speed will be 0 because it starts from rest, and after 10 seconds they are asking 10 seconds. Okay. And mechanical power equal to rate of change of kinetic energy, right? Rate of change of kinetic energy, which is nothing but I am starting the car from rest, u is equals to 0. After some time I need to know the velocity, at which time t is equal to 10 seconds. So change in kinetic energy divided by time, that's it. Okay. So when we take d by dt of 1 by 2 mv square, which is nothing but only v is changing, right? No, m into v dv by dt. Okay, I can say this constant, 1 by 2 is constant. So this has been written as mass into velocity. So dv by dt into mass into velocity, right? So mass into velocity I will keep as it is, dt I will take one side, and m also other side, and differentiate v, so integration v dv will be equals to p by m into dt. Integrate on both side, 0 to v, 0 to t. So of v square will be equals to p by m into t. So I need to know what is the velocity. So it is 2 pt by m, which is in under root. So 2 into 10,000 into 10 divided by 2000. How many zeros will get cancelled? 1, 2, 3, 1, 2, 3, and this 1 and this 1. So this will be 100, which is nothing but 10 meter per second. So option D is the answer, right? Option D is the answer. It's not B, it's not C. So we have done some calculation mistake, right? So check it out, right? So this is the answer for the given question. So okay, next question is, two bodies A and B of masses 20 kg and 5 kg respectively are at rest due to the action of the force 40 Newton separately. If two bodies acquires equal kinetic energies in time Ta and Tb respectively, then what is the ratio of Ta and Tb? Okay, so what is the thing they are saying? Mass of A is equals to 20 kg, mass of B is equals to 5 kg. So respectively are at rest. Okay, fine. Due to action of the force 40 Newton separately, if two bodies are acquires equal kinetic energy, so kinetic energy of A will be equals to kinetic energy of B, right? This is the condition. So what is time A and B they are asking, right? So what will be the answer for this question? Give answer first, we'll see. After finishing, no, we'll go for the answer, like what will be the answer. Okay, give. Done? Okay, we'll go for the answer now. Okay, fine. So the thing, yes, mass is there 20 kg, 5 kg, and the force is 40 Newton on each. So acceleration will be F by m, no, F by m. So we know that V is equals to AT, like A is nothing but V by T. I can say V is equals to AT, right? No, AT. So AT, okay, fine. We don't know like A and T, like we can, in terms of, we can write force and mass. So F is equals to ma, A will be equals to F by m. So I can substitute this here, V is equals to F by m into T. That's the thing, right? So kinetic energy of mv square, right? No, instead of v square we are substituting ft by m the whole square, right? So ft square, f square, t square by m square will come. So 1 m square and m will get cancelled into 2. So f square t square by 2m, right? So force we know, force also equal, right? So I can cancel it out. This force and this force I can cancel it out, and this 2 to get cancelled, right? So ta square by tv square will be equals to, what will come? ma will come there, mb will be down. So 20 by 5 once, and this is 4 times. So answer will be 2:1. That's it. So option B is the correct answer. Option B is the correct answer. Right? Can we go for the next question? Okay. So a crane of efficiency 80% is used to lift 8,000 kg of coal from a mine of depth 108 meter. If the time taken by the crane to lift the coal is 1 hour, then the power of the crane is, they are saying 80%, like crane efficiency is 80%, to lift is 8,000 kg. So 108 meter, and in 1 hour, what is the power? Either it's 5, 4, 6 or 3 kilowatts. Okay. Now, so efficiency nothing but like 80% means 80 by 100, which is nothing but 0.8, right? So mass is 8,000 kg, depth is 108 meter, and time is 1 hour, which is in seconds is 3600 seconds. Okay. So work done to take it out, which is nothing but lifting the coal, mgh. 8,000 into 10 into 108, which is nothing but 8.64 into 10 power 6 joules. Then output power, like power output will be equals to work output by time. 8.364 into 10 power 6 divided by 3600, which is 2.4 kilowatt. 2.4 kilowatt. Then efficiency is nothing but power out by power in. Right now, power out by power in. So power in, I need to get it, how much it has been in, like out by efficiency, which is nothing but 2400 by 0.8, which is around 3000 watt, which is nothing but 3000 kilowatt. So option D is the correct answer. Option D is the correct answer for this question. Okay, you can take the note of this question. Okay, how to proceed, how to do when efficiency question is given, how to proceed with that. Okay. Done. So next question is, a train of mass 10 power 6 kg is moving at a constant speed at 108 km per hour. If the frictional force acting on it is 0.5 Newton per kg per 100 kg, okay, then the power of the train is, what is the power of the train? Okay, when they have given the frictional force, how we need to proceed, right? Yes. So mass is given, speed we know, that is 108, which we need to convert into meter per second. 108 into 5 by 18, 5 by 18, 1 times, and this is 6 times, which is nothing but 30 meter per second, right? So frictional force 0.5 Newton per 100 kg, right? No, 0.5 Newton per 100 kg, right? Yes. So F is equals to 0.5 into 10 power 6 by 100, right? 100, which is 5000 Newton, 5000 Newton. So if we know speed, if we know force, force into velocity is power, okay. So 5000 into 30, which is nothing but 150,000 watt, which is 150 kilowatt, 150 kilowatt. This is the answer for the given question. Okay. So next question is homework for you. Yes, this is the homework question. A body is moving along a straight line under the influence of constant power source. If the relation between displacement s and time t is, s is directly proportional to t power x. So then x will be. So this is homework question, okay. So please try to complete this question before coming for the next class, okay. And whoever watching in online, they can give answer in the comment boxes. So we will cross verify the answer. If it is wrong, we will mention the answer key, okay. If it is correct, yes, no issues, right. Okay guys, so with this we will complete the session of today's class, okay. Thank you guys, we will see you in the next class, okay. Bye.